Welcome to this CER tutorial. This is for Physical Science 2 Learning Set 2. So you've completed the test and now you've been assigned one of three videos, or maybe two of three videos, or maybe all three of the videos, depending on how well you did on your CERs. So this is going to be the tutorial for claim. Now remember, your claim is a statement about the results of an investigation. And in many of the CERs, we give you the data. And it's your job to interpret the data, the results of the investigation, and to answer a question. So when it says here a one-sentence answer to the question you investigated, make sure you answer it completely. And if you look at the third bullet, it says it should not start with yes or no. So the answer to this, some of you just wrote down number 2. And my question to you is number 2 what? Energy conversion diagram number 2 is the best choice. It's 2 o'clock. I'm not sure. So make sure it's a full, complete sentence so that whoever's grading your paper, mainly it's me, knows exactly what you're trying to state. And it should describe the relationship a lot of times between the dependent and independent variables. So let's get here. So here was the question you were supposed to answer. Which energy conversion diagram is the best example of a tennis ball at position 3? Now, the first thing you need to look at here is which energy conversion diagrams. And some of you got a little bit confused with this. There is one conversion diagram right here. Here is your second one, and it's labeled number 2. Here's the key. And then if I was to draw here, here's 3 and here's 4. Some people got mixed up with this. They didn't know which one was the energy conversion diagram. Some of you said the left or the right side. Or some of you didn't even tell me it was number 1, number 2, number 3, and number 4. You didn't answer the question at all. And it also says at position 3. So position 3 is right here. Now, you might be wondering, why are the scientific principles here if we're trying to answer the claim? Many times what you want to do is you want to look at the scientific principles, and they will help you determine which one of these is correct. So if I start looking through the scientific principles, any moving object has kinetic energy. Is this a good one to use? Well, this one has Ke, this one has Ke, this one has Ke, this one has Ke. All of them have Ke, so this really isn't helpful at all. This one I can just cross off. How about number 2? An object's kinetic energy increases as its speed and or its mass increases. Now, you might be saying, well, that's not very useful. They all have Ke going up or down. However, some of the Ke's are going down, some of the Ke's are going up. So this is actually pretty useful to use. How about this one? An elevated object has gravitational energy. Well, they all have GE. Position 3 is elevated. So number 3 really doesn't help me either. It's too general, similar to what you saw in number 1. How about number 4? An object's gravitational energy increases as its elevation and or its mass increases. So if I went from position 1 to position 2 and now I'm at position 3 because it says it right here, and if I look at this, GE is going up here and it's going down here. So this one right here is actually going to help me figure out which of these is going to be the actual answer because the GE changes from one to the other. Energy can be converted, transformed from one type to another. That really is not necessary. I don't need that one because we know that with all these going up and down, there's all kinds of energy being converted within all these conversion diagrams. How about 6? Any deformed rigid object has elastic energy. Now, when I look at that one, I'm thinking, okay, look, this one has elastic energy. This one has elastic energy. These do not. So because some do, some don't, I think I'm going to be able to use 6. How about 7? An object's elastic energy increases as its deformation and or rigidity increases. Well, we're at position 3. So we do not have to worry about that because it's not, the amount of EE is not increasing or decreasing. Energy can be transferred between systems. Well, this is all one system, so we don't need that. Energy cannot be created nor destroyed. Really doesn't help us at all. So I've already given you some of the scientific principles you can use, and we'll take a look at those a little bit later. Now let's watch this. look at these arrows. This is a huge piece of evidence we're going to use later. So this tells me it's going down. So if the ball is dropping, what do we know about GE as a ball loses elevation? The GE has to be going up or down. Well, if it's losing elevation, GE must be going down. So that tells me right away that this one's out. It also tells me that this one's out, because here GE is going up. Well, if the arrows show that it's going down, it's got to be one of these two. Now, there's two different things you can use to figure out which one it is. One, if it's in the middle of the air, is it going to have any deformation? No. So it won't be that one. So when you look at it, you could use that one's really the eliminator. The other one you could talk about, well, if the ball is going down, the KE is going up. But that will still give you these two, and it won't tell you which one. So you have to use scientific principle number 6 to help eliminate this, which means the correct answer is number 2. So here are some examples of claims you could have. For example, energy conversion diagram number 2 best represents the tennis ball at position number 3. Or energy conversion diagram number 2 is the best diagram for a tennis ball at position 3 because the ball is losing GE and gaining KE. Both of those are awesome. Both of those would be scoring at this level. How could you get a 3? Maybe you just said energy conversion diagram number 2. You're correct. I'm going to give it to you. I'm not going to give you the 4, but I'm definitely going to give you the 3. So how could you get a 2? You might have just said number 2. So did you make an accurate claim? Yes, but it's incomplete. How could you get 1? You just flat out get it wrong. So go ahead, make sure you watch the video, make sure you answer all the questions correctly, and hopefully this will help you the next time we take a CER test, and hopefully you'll be able to use the scientific principles to help you figure out what the claim should be. Again, as always, if you have any questions about how to write a claim, make sure you see your teacher. Thank you.